Okay, this is the first solution for the review problems for the mock exam. Um, First problem from page 34 of the book, we are going to classify these numbers into the N, Z, Q, and R categories. To refresh your memory, N is natural numbers, which are the counting numbers, okay, the positive integers, including 0. And then Z are integers. Q, you can remember Q is quotient, which means two numbers dividing each other, two integers dividing each other. Those are the rational numbers. This is the most confusing one because the R could be confused between rational and real. R is real. Okay? Real numbers are all the numbers we study in math studies. The only ones we don't study are the imaginary or complex numbers, which include the square root of -1. Okay, so that doesn't exist in our class, so those are the real numbers. Okay, so you need to memorize what these letters mean for May of 2015. So let's start with the easiest one, 5. Okay, 5 is a natural number, right? And so once you know it's a natural number, it's also an integer, it's also a rational number, and it's also a real number. Now let's look at pi over 2. Pi over 2 it looks like maybe a rational number because it's a number divided by another number, but the top number is pi, which is 3.14159, and actually it goes on forever, never repeating. And so that is the definition of an irrational number, a not rational number. So we know that pi over 2 is not a not rational number because if you start with a not rational number of pi and you divide it by 2, you're still going to get a not rational number. So the only thing it is a real number because this is a quantity that exists in the physical world, and has nothing to do with the square root of -1, right? -3, okay, it's not a natural number because it's negative, but it is an integer. It's a negative integer. So it is included in the other categories too. 5 divided by 4, it's not a whole number, so it can't be a natural number or a Z integer. But it is a rational number. In fact, it looks like the definition of a rational number. It's got a whole number divided by a whole number. It's got an integer divided by an integer, so that is a rational number. Real number, it is also. And 2.3333 repeating, this dot over the 3 means it's repeating. Remember that if you have a decimal where the number pattern after the decimal repeats itself after a while, that means it is a rational number. Anything in this form can be converted into a fractional form, okay? And your calculator can do that for you. All you have to do is um, put it in the mode where you want it to display in fractions. So let's go down to, let's see, that would be this one here. Okay, if you ever want to change from a fraction to a decimal to a fraction, you just put that output mode, and then you just put the decimal in there with as many digits as fits. So I'm just going to put 2.333 all the way across the screen, which is the number that we have here, right? Then I'm going to hit enter, and it gives me the fraction. Okay, I put enough digits so that I fooled the calculator into thinking this was forever, and it showed me that it's 7/3. Okay, and then to go back to the normal mode, I just press mode. And then I go down to where it says auto decimal fraction. I'm going to put it back in decimal. Okay. Okay, so that was the problem from page 34. Now the problem from page 35. Total mass of 90 identical books is 52,200 grams. Calculate the exact mass of one book in kilograms. Okay, so the only tricky part of this is changing from grams to kilograms, because figuring out how much one book weighs is pretty easy, right? You just take the total weight, 52,200 grams, and you divide it by the number of books, 90, and that gives you the weight of one of the books. And so 52,200 grams divided by 90 gives you 580 grams. Okay. Now the only tricky part, they asked for it in kilograms, not in grams. So, and actually, when I did the solution, I didn't notice that they said that. So I just wrote 580, but actually, I do need to write it in terms of kilograms. So my answer was wrong. So this is 580 grams. I need to write it as kilograms. How do I write it in kilograms? Well, let me find a little empty space here to write it, and I'll write it here. 580 grams times a conversion factor is equal to something in kilograms. Now, what's the conversion factor? Well, the conversion factor is going to be basically a number over the same number, but we're going to use that trick. If I put down here 1,000 grams, and I put up here 1 kilogram, is that equal to 1? Is 1 kilogram divided by 1,000 grams equal to 1? Yeah, it is, because 1 kilogram is 1,000 grams. So I have one quantity over another quantity, which represents the same amount, that's equal to 1. So I can multiply by 1, and I'll still get the same amount out. So 580 grams times this factor still gives me something that is equivalent to 580 grams, which is, so I cancel out the grams. Do you see how I can't confuse which one goes on top, because the grams have to cancel out and the kilograms has to be left. So 580 divided by 1,000 is in the end what I need to do. And if you do that on your calculator, you would type 580 divided by 1,000 and you would get 0.580 kilograms. Okay? So the answer to part A is this. Okay? And then in part B it says write down your answer to part A in one significant figure. I wrote it in grams, but I need to write it in kilograms. So let's write the answer for part B here. It would be one significant figure. One significant figure would be the first significant figure of 5. So I want to keep that. But do I want to keep 5 or do I want to round it up to 6? Well, I take a look at the 8, and that tells me that I need to round the 5 up to a 6, right? So I would put 0.6, and then the rest would just be 0 because I've gotten rid of those two. And actually, I don't even need to write them anymore because I only need to write one significant figure, right? So it would be 0.6 kilograms would be the answer for B. Okay? And so that would be one significant figure. Matilda estimates that the mass of any of the books is 0.4 kilograms. She used the result to part B to find the percentage error made in her estimation. So remember that some form of this is in your formula sheet, but the exact measurement minus the estimated measurement divided by the exact measurement, absolute value at the top, is equal to the percentage error. So we are going to put the exact measurement, which we know is, and here once again, you can use kilograms or grams. Let's say I used grams here, but let's use kilograms because that's what Matilda said. She said 0.4 kilograms. So I'm going to change everything to 0.6, 0.4, 0.6, and in the end, it's not going to make any difference. You will see. Okay, so I changed everything to 0.6 minus 0.4 divided by 0.6. That's going to give me, on top, it's going to give me 0.2. So do I need to take the absolute value? No, because it's already positive. I divide 0.2 divided by 0.6, and that, if you can do that on your calculator if you want to, but you will just see that it equals 33.3%. Okay? So that's the answer for C. Okay, so moving on to the page 35 problem right here. Okay, for 35 problem, the page, let me just go ahead and do the division now that the calculator finally woke up. 0.2 divided by 0.6, oops, calculator is really slow today, is 0.3 repeating. Okay, so that is equal to 33.3%. Now, remember that when you want to convert this to a percent, you need to multiply by 100. When you want to take a percentage and you want to convert it to, let's say I had 33%. If I want to convert this to a decimal, I need to divide by 100. Why 100? Because percent means per 100, right? So 33% is the same thing as 0.33. Okay, so I put 33% here. Okay, right here is the answer. Okay, now last one for this video. We're going to talk about what you get when you take 30y squared and divide it by square root of y plus 1. First they tell you, this is just an exercise in scientific notation and significant figures. So the first part is pretty easy, except for if you are not good at using parentheses on your calculator. Find the exact value of x when y equals 1.25. Hey, that's easy. I just put 1.25 in there. I put 1.25 in there. So it kind of looks like this, 30, 1.25 squared divided by square root of 1.25 plus 1. I advise you to do this on the test because if you screw up with the calculator, you might get part of the points. How do you put this in your calculator? Well, you have to be careful that when you do the 1.25 plus 1, put parentheses around the 1.25 plus 1, otherwise you might get the wrong answer. So we'll do 30 times 1.25, and then we'll put squared, and then we have to press the right arrow so that we get back down to the bottom, and then we divide all of that by, and I'm going to put the square root. Okay, and inside the square root I'm going to put 1.25 plus 1. Just to make sure that it groups everything together, I'm going to put a parentheses. 1.25 plus 1 parentheses. Okay, and then I can get out of there. And it gives me 31.25. Now it asks me, that's the answer for A. B says write down the value of x correct to 3 significant figures. Well, the 3 significant figures would be 3, 1, and 2. Now, what do we do with the 2? Do we keep it or do we round it up? And we're going to look at the next number, which is the 5. The 5 tells us we need to round it up. So instead of 312, it'll be 313. Keep the decimal there. So the answer to B would be 31.3. C, write down your answer to part B in the form of scientific notation, which is, the first number has to be between 1 and 10. Could be 1, cannot be 10, it can be 9.99999. 10 to the k has to be a positive or negative integer. So to change this, we can see that we do need to move the decimal point one place. So we would put 3.13 times 10 to the first, right? And how do we know it's 10 to the first? Well, we can multiply it out and we can say, hey, 3.13 times 10 to the first, 10 to the first is 10. So that means I moved the decimal place out 1, so it's 31.3. Oh, I got the right answer. If you're not good at that, you could use the calculator. You could put the calculator in scientific notation mode, and then we go back here, and then we just type in the number 31.3, and the calculator gives you the answer, 3.13 times 10 to the first. Do you see the E1? That just means 10 to the first. So there's no excuse for getting these problems wrong. Your calculator does it for you. You just need to practice a little bit and remember. Okay, so that's the first page of the review sheet, and I will put the others problems in other videos.